Good morning, everyone. Thank you very much for attending my talk today. In next probably 35 minutes, I'm going to share the journey that we had for just implementing a cloud platform for data science, enabling you guys just to develop and deliver your model. The last step of building every model is exactly the challenging part that we were facing with, but thanks to the new technologies that I'm going to share with you, it looks like a resolved issue, hopefully, after this talk. Okay. So as it was mentioned, I'm chief data scientist at R-Brain. It's a cloud platform for R and Python that you can actually develop your model on the cloud. That's actually exactly the same experience I explained that I'm going to share with you. Let's go too fast. All right, so as you know, when you build a model from end to end, you are facing several steps, starting from data preparation, development, collaboration, getting feedback, or probably validation, and then just ship it and share it with your users. These actually steps are, each of them has its own challenges that I'm going to explain, and the practical solution that we try, and we were successful on that in post-data preparation phase. So starting with development, that's the first part of challenge, whether you are inside your organization starting to develop a model, or whether you are as an individual developing an idea you would like to share with your community or ship to your clients. This is the first step that you are facing with. The first step is different tools. Inside an organization, definitely it's a challenge that some of you guys like to develop in R, some of them you guys like to develop in Python, Scala, different languages. And we see that each organization is targeting one of these particular tools. And within our organization, you're facing with different tools and solutions that needs to be implemented in our organization. So maintaining these different tools, integrated them in one environment, using them is the first challenge that you are facing with. And also as an individual, you get used to your environment. You use like a kind of IDE that you're using, then it's a new language is coming in. It's quite challenging that switch your environment because you're familiar with the environment that you used before. In pure software development, it's a pretty mature set of tools that are available, like for example, Eclipse, that you have different languages. But the part was missed in data science world. And definitely the best way is to have an integrated IDE that supports our languages at some kind of kernel base and to be actually extensible, let's say. If you hear about Jupyter Lab project, for example, which is a new extension of Jupyter, it's not a notebook anymore. That's a very nice move going forward, that you have an integrated environment, you have your IDE, console, terminal, notebooks, and with different language kernels. So it's two-dimension is extensible. Whether you want to go beyond on one language, Python, R, Scala, and whether or you want to go to further to other stage of just using notebook only, scripts, or just use console, for example. The next challenges start with, in development environments, the friction between IT and developers. Definitely, we as developers prefer to have root access. We want to have actually flexibility. We love microservices, whereas in IT world, they want stability. They want security. That makes a lot of sense. So it's starting point of friction between two that, of course, make some compromise between security and flexibility or even performance going forward. So current solutions for this part are server-based IDEs, virtual machines of actually another solution, but we love containers. We love actually the new technologies like Docker that actually helps a lot in this environment. Server-based IDE, you know that again, it's a good way, but usually they are built for particular languages. The second problem with server-based is, again, just allocation of resources. We have a server allocated like 100 gigabytes of memory to all users, but we really know the trend. Or if you have a memory leakage in our code and one user do something wrong, it's just consume all the resources. There is a risk that the whole platform goes down. I'm sure that if you use these server-based IDEs, you face these problems a lot of time. And for VMs, of course, it makes actually that part much easier. It creates different isolated environments. But the problem with virtual machines is they are heavy. They are, and of course, they are not built for sharing and collaboration. Everybody is completely in complete isolated environment. So definitely making collaboration and make connection between these environments is really challenging. And of course, like, I don't know, for Python, for example, when you build a simple VM with an IDE packages tools, it comes to like a VM with 3-4 gigabytes of storage. And nobody likes to share such a huge amount of actually storage with someone else, let alone to be just 100 people, for example. So containers like Docker technology helps a lot. I will talk about more in details about container, but what I would like to emphasize that these technologies solves almost every single step that we go forward, starting from development. Resource allocation is another challenges that we have. So like I have banking experience. During the period of some DFAS or CCAR, you're in banking, you're familiar with these terms. It's a huge demand for just running models, generating reports starting probably in late year and goes like, for example, November and December and goes to February and March. That's the peak of work. And just in those banks that I used to work with, to serve that short period of time, they needed to allocate a lot of resources, but for such a short period of time. So it was completely waste for the rest of the time because they had no other ways. They needed to serve the clients and the developers within this period, for example. Or as an individual, you have your machine. You are actually working, your limitation is the processor and hardware that you have on your machine, whereas you would like to go beyond and just to train your model and run your model later on. And here is actually cloud platforms helps you a lot. That's exactly on-demand resources are available for you. And again, coming back to the container technology, using cloud platform in combination of new technologies like container helps you a lot to just to build, to support your development in a much more flexible way. Next step is you're in collaboration stage. So the first challenge is reproducibility. It's very important. You know better than me that how important it is that when you ship your model or you deliver your model to someone else, they should be able to, first step is just to be able to reproduce your results. And then you can encourage them to contribute, receive comments, or extend that research so it's a benefit of your community. But the first step, which is the challenging one, is just how you can build an environment for others to be able to reproduce your results. So there are just best practices. You know better than me. I don't want to talk about that. You're all professional. Just to say, for example, treat your code, your data, clean your data, everything in your script, be clear step by step, use relative path. We know all these things, but use Git and GitHub collaboration tools, for example. But again, we know that still it's not working. It's, you just push your model to GitHub, you explain all the steps, and you receive feedbacks from different users. Oh, it's not working. Which package you use, which one you installed, which version you use. And it's open source community. You know, it's going really fast. You will see a lot of changes day by day or even hour by hour. So how you can actually support that part and help them out to be able to reproduce your result is really a challenge. And again, as I mentioned before, container technology helps you a lot. When you are able to ship your model, all the specification, dependencies, codes, everything as a container, and it's not that heavy as a VM, by the way, and you can ship them out to your user. And the first step, when you are able to run your model in your container, they're also able to do the same thing because they are exactly replicate the same environment that you use. So it's resolved a lot of things. It saves a lot of time. And of course, it helps your community to reproduce and start to collaborate with you and extend your research, for example. Or even if you are inside an organization, just give you another example from my experience. I was in model validation. When model developers were done, they were supposed to send over the whole models to us to start the validation. And that was the first problem, because we spent weeks, not days, weeks, just to set up the environment. We just noticed, oh, this is not the package they use. They use different version. They use this script. Sometimes they hard-coded the path and dependencies inside their code that we need to trace them out and find the relative links and make changes similar to our environment. So just imagine that in case of like doing in a conventional way, just the model would be shipped as a container, and we were able just to start a validation with the main task we were supposed to do, rather than to spend a lot of time and back and forth to understand and set up the environment first. Communication, definitely, it's an issue. One of the main differences between building model and pure software development is the interaction that we need to have with subject matter experts. We need to be in close connection with business unit to understand whether the model is practical. We cannot go pure technical. Again, just give you an example from banking. I may come up with a pricing model that I find age is a very nice factor inside that and explains the, for example, creditworthiness of the borrower very well. So I build a model, I have age in my model, I send it to the business unit, and it gets returned immediately because it's against law. We cannot actually have age in the model, for example. So it's not pure technical. We cannot just go exactly based on numbers and based on the T-stat, p-values, or MSE, or AUC, other factors that you know better than me, and make a decision. So again, how we can just make this interaction more efficiently between developers and business units. You are familiar with notebooks. That's a very nice tool. I love it very much. You can explain the process, and they don't need to go to technical. They can see the result, and they can comment and send you feedback again. And the other things, actually, sometimes you want to give some flexibility to them to give you feedback. Again, it would be a very big challenge to set up the environment for them to be able to just reproduce your result. Again, coming back to container technology, they are able to just replicate the result in the environment and send the feedback right away for you. And of course, hardware and software resources, when you just want to make a collaboration, is another challenge that Cloud Platform helps you out to provide infrastructure on demand right away for them to receive the feedback. When it comes to delivery and development, again, we are facing new challenges. So one main challenge is we build a model, we generate a lot of numbers, factors, statistics. They're very interesting, we love them, but probably business users, they don't have any good sense about these numbers. So we need to interpret this result for them. We need to share the outcome in a clear way. So fortunately, there are a lot of good web application frameworks already developed, and they're open source, like Shiny in R or Bokeh in Python, that we can leverage them and share the result in nice and clear way with minimum knowledge that we need in web development or JavaScript, for example. These are very nice tools that we can leverage. But when we do so, still we are facing the problem of scaling allocation resources. So when you generate a dashboard and you just want to share it with 20, 30, 100 people, it depends on the complexity of your model. You need to allocate actually a good amount of resources to be able to serve them. So how much you would like to allocate? If you want to be conservative and allocate a lot of resources, then it's not feasible. You face it's costly, let's say. If you want to apply a scaling algorithm to just scale out based on, for example, a query or actually request to your service, then you need to implement a scaling algorithm or infrastructure. So it really comes to a challenge. And again, container technology. It's because what you can do is simply you have, instead of just bringing all users, everyone in a single environment and allocate a lot of resources and to serve them, you can enable them to just replicate exactly your environment, not necessarily just do the final step. It's possible to apply it in an automatic way. And each user is a different container. They're in their environment. There is no security risk of just exchanging data, leakage, security issues, as well as just applying scaling. Just imagine that when a new container is coming in, you just allocate your resources to that special container that you have a good sense about it because you build the model. You have a good sense about the resources, the storage, the memory that you need. You can, even you go for scaling, you can build a much, much more sophisticated way of scaling rather than just to have a forecast that bring all users to one place. And of course, as I mentioned, security and access control is much easier when you use container, but again, using a cloud platform, you can define particular access to each user, whether it's actually through credentials, other way of authentication, IP restriction. You have a lot of flexibility using cloud to define a very nice, secure, and access control to your users. So I mentioned a lot about containers. So I'm not actually a software developer, even I'm not able to go really to pure technology behind container, but as a user, as a consumer of container, what I can share with you about this nice technology is its flexibility that you can. I discussed about all three stages of development, delivery, collaboration using this technology, but this actually picture explains why you can do that in such an easy way. You have your infrastructure, all resources that you can allocate to your users. You have one layer of operating system. And you have your Docker engine, was one of the technologies that handle containers for you. As you can see, your applications, your libraries, dependencies for each application is seated separately in different environments. The main difference that you see between virtual machines and container is just that extra layer of Docker engine that saves a lot of complexity in your work. So in VMs, you have, it's virtually a virtual hardware you build. You have your own operating system, and that's why they are so heavy. And that's the difference here that we see in container, that you just have your dependency on the sharing G, but in different containers that makes the collaboration or delivery much easier and in much easier and more efficient way. So what happens in the container is it's exactly you wrap all piece of software in a complete file system. So it looks like I build my model in my laptop and I ship my laptop to you. So when I'm able to run everything on my machine, so you are able to run it on your machine as well. So it's just explained in a simple way. And that's why it guarantees that the software, the model that you ship, that run exactly the same way regardless of any other local environment that's sitting there. So in conclusion, with containers, we kill localhost. Localhost is dead. We don't need localhost anymore. And that saves a lot of time and money for developer and consumer of your model. Using cloud, I'd like to share some numbers with you based on the IDG research applied in last July. By using cloud, you can see that 39% of early adopters, they were able to increase the storage demand. 38% of them could make IT people free that do much more sophisticated things rather than supporting different tools, environment, or set up, or allocate resources, manage, or orchestrate the things behind. 36% of them have, 36 actually, more than one third of them have the faster time to market. So coming back to my point, that's exactly the thing. So when you're able to to easily scale, easily deliver. So it saves a lot of time and money for you, and you are able to ship your product much faster. And I'm not surprised that 36% of them could actually achieve to faster time to market. 39% of them actually save a lot of costs. The banking example was a good one. Just for a couple of months period, you need to allocate huge resources that is going to be obsolete maybe in 2-3 years. And you need to hire actually an army of support IT people to support that load for just 2 months, for example. Just compare it to an on-demand resources that you can leverage any time that you would like from cloud. So it's not a surprise, almost 40% cost saving in your application. 38% improved their disaster recovery plan. Again, just leveraging the infrastructure available by cloud providers. You can set up a very nice, reliable disaster recovery plan. And of course, almost half of them increase their agility and responsiveness to business demands. That was exactly one of the parts in collaboration was a good example that I mentioned before, that you see that it's the concept is sitting there, and we see that it's real in business. 50% of them actually could increase the collaboration, the efficiency between the developers and business demand. All right, so these are the good thing about containers, cloud, so how you would like to apply them in your business. Still, it's challenging. Still, it's not, unfortunately, that straightforward. So you start with development environment tools, everything that you would like to have in your organization. The first step, you need to build and maintain images. So Docker images are exactly, you remember in the graph, we had an extra layer of Docker engine. So that's when a new container is created, what happens that they pull the resources and set up everything from images, and then you have the volumes that are going to be installed on your system to have more flexibility to the user. So the first step is how you would like to develop and define your images. That's the first step. And the second step is just to provide a system of installation of system libraries and containers. It's again under your control. You have the flexibility here, which is a great advantage, but it's also very dangerous because it's very important how you define that, especially at the first step. If you go wrong, it's very hard to come back and just reset up everything from the scratch. Say, for example, you want to give the flexibility to users to be able to install new libraries in their environment, for example. That's a good advantage. That's a great deal. But imagine that you just override many of them through your images if you have some similar setup. If in your image you have a library X with version 1, and you enable user to do the same thing with previous version. And what happens here is when the image is called and the container is built, the previous library is overridden. So these are the kind of policies that you have to make it clear for your users and give the flexibility, but without any compromise in the way that you really aim for. So container orchestration is another challenge. Yes, it solved a lot of problems as we discussed about allocation of your resources or provide the infrastructure for your users. But still, we need a lot of orchestration is the best word, that how you allocate for each container you would like to define to resources. You want to give them flexibility to user define the resources, or it's already allocated, for example. You would like to apply different restriction. And when it comes to production, what happens when new demands come for new containers? What's going to happen between different users when they clone your work environment to go and redevelop or extend your research, for example. This kind of orchestration, again, needs some setup and implementation that you need to take care of it within your organization. And definitely, as an individual, it's not expected to be done by a data scientist. It's just pure DevOps. And it comes to deployment. That's the first and sweet part, that now things are available for development, building model, and going forward. Hopefully, you agree with me, go to cloud. So these steps, we had this journey in our brain. So here what we have, we just built images. We take care of all this actually library and installation, container orchestration and deployment. These are the phases that are applied and we implemented them in our platform that I quickly would like to share with you. You remember I mentioned about Jupyter Lab project. So our IDE is exactly built on this open source IDE. It's a new project. It's available on GitHub. It's a fantastic tool. And as I mentioned, it's extensible in 2 dimensions of just adding widgets, views, languages based on kernels, as well as the just going pure to coding, building notebooks, or even have a terminal emulator for your root access. For building and maintaining images on our platform, we have pre-set up images. And for our public cloud, these are already there. As an individual, you can leverage them and use them right away. They are fine-tuned and ready, hassle-free. You can use them without any problem. And within your organization, we can help you out to just set up these images for your use. When it comes to installation of library and file system, we definitely, one part we leverage the advantage that we have in flexibility of Jupyter Lab, but also when it comes to just managing your databases, bringing them from your inventory, managing your file system, we take all the things and it's already done in our platform. And when it comes to orchestration, in our brain platform, you can share, you can pack your Shiny or Bokeh application and send it out as a container. You can have different workspaces, each workspace completely isolated from other environments. That we do all this orchestration and management in background without any headache for users. And when it comes to delivery and deployment, again, users are able to just run the application right away without going to like a Shiny app, for example. You don't need to go to our environment, run it. Everything is in a container. It looks like a exactly ready cloud web application that you can click and run it. And when it comes to sharing, the same thing. When you share your notebook or project, they're able to clone your environment and able to reproduce the result right away. So as an individual, you can leverage all we have. You have on-demand workload. You can scale in and scale out anytime that you would like. You can collaborate. And also, as I mentioned, you can deliver your results swiftly. And as an organization also, we can help you out to build your images, set up your images, implement your cloud, exactly the same environment that we see on our public cloud. And we also help you out to maintain and support your environments. All right, that's all about the container technologies and our brain. And I'm here to any question, concern. Yes.
When I have to share the model with somebody else, if they are a non-technical or a business user, what needs to be done? I just give it a URL and that's it?
Yes, that's exactly you can do. If it's just a panel or dashboard, they can run the URL easily. Or you can make it a Shiny application. They can run the Shiny without any problem.
How does it work for Python and
It's the same thing. You can export your environment as a Shiny app. And
Shiny is only R, but I don't care about R.
For Python, we do now for Bokeh, but we are just making a generalized framework for other solutions, like for example, Flask. You don't need, no. What we do is just everything is UI. You just click, make a container, ship it, and they're able to run.
Okay, let me ask you, maybe I'm not, suppose I have to share with this person.
Right.
It is not my tool.
Right, okay.
I'm not saying don't take it.
Right.
I just want to send him an email. This is a link. Please validate the data.
Right. Yes. What you can do is you just run if it's an application, your Shiny application, you should send a link. They just open the link and start to use.
So will I have to buy a subscription for this person?
No, they don't. No, exactly. They don't. Yeah, that's true. Yeah. You're welcome. Yes. Can you? Yeah, I cannot hear you. Just could you?
How much of, I mean, by adopting containers, how much overhead does that add on the engineering side versus the data science side with orchestrating and maintaining the different versions of the containers? And also if that limits the flexibility on the development side for data scientists?
Oh, everything comes to how you define your images. So, of course, there is actually a trade-off here between the flexibility that you give to your users and your image. You can make your image as big as you'd like, add all libraries, all dependencies, everything. What actually happens, it gives less flexibility to your users because now they are limited to what you define in your image. But what happens, it gives you more flexibility in your shipping your model because whatever is in the image is not needed to be shipped. The rest of the work that you build on top of that is going to be shipped. So it's completely on your control. So it's you as the owner of the model should think about how you would like to make this balance between how complicated is your image and how we would like to give flexibility to end user.
And so I haven't worked with containers, but
right.
Is it, you have a few containers that are shared by many of the data scientists, or each data science, depending on the project, they work on their own container for every individual project?
Right. What happens is if you just want to do it purely outside any context of cloud or things, what happens is you just run the container. You choose, for example, Docker. You run your model inside your Docker image. You set up everything. And what you do is you commit your actually current state of your environment, and then send that container as a file, as a tar file. Then they can open up and run your environment right away. Yeah.
Thank you.
You're welcome. Any other question? All right, thank you very much.